Hello there, you are welcome to TNS Digital Mathematics class, and our topic today is mensuration. Mensuration. For this class, I need you to be with your book, your pen, and a calculator. You'll be needing that. Another thing I need you to be with in this class is your keen attention. I want you to follow me at every step of the way, keenly. Are we ready for this class? Let us roll. Mensuration. The word mensuration is a familiar topic in mathematics. Mensuration talks about measured properties of shapes. Oh yes, there are different types of shapes, and they are categorized as plane shapes and solid shapes. What are plane shapes? Plane shapes are shapes whose line joining the shapes is presented on a plane surface. Plane shapes examples are square, circle, rectangle, triangle, and so many more. For a square, it is presented on a plane surface, something we can see. We can see all the edges that bound a square. Triangle, for another example, is also a plane shape. We can see all the edges that is formed as a result of the lines meeting together. So plane mensuration deals with plane shape, while solid mensuration deals with what? Solid shapes. Solid shapes, on the other hand, are shapes whose whole body cannot be presented on a plane surface. Example of such shape is a cylinder. For a cylinder, take for instance a tin of milk. A tin of milk has the shape of a cylinder, right? If you see the top of a tin of milk, can you see the bottom? Can you see the bottom? No. So the fact that the bottom cannot be seen makes it a solid shape. If we are even looking at the front side of the tin of milk, can you see the back side? No. So the fact that you can't see every other part, all the parts at the same time of a particular shape, makes that shape a solid shape. So a solid mensuration deals with the properties of a solid shape. It deals with the properties of what? Solid shape. That is what we shall be looking at today. We shall be treating solid mensuration. Solid mensuration has properties of many solid shapes under it. Solid shapes such as cube, cuboid, cylinder, cone, sphere, and pyramid. All of these shapes are known as prism. The word prism is a general word that is used to define a shape whose whole body cannot be presented on a what? On a flat or plane surface. Are we ready? Let's move on. Cube. A cube has 6 faces of equal dimension. An example of an object that has the shape of a cube is what? Thank you. Just like a cube of sugar. A cube of refined sugar. Good. A cube of sugar has how many faces? 6 faces. Oh, thank you. Another example. Another example is the dice. Yes, the very familiar dice that is used to play Ludo. A die has 6 faces. All of these 6 faces cannot be seen at once. That is why it is also regarded as a solid shape. So we have the surface area of a cube to be 6. How many faces does it have? 6 faces. 6 times area of one face. We said something has 6 faces. One face, each of those faces is made up of square, isn't it? This is square 1, this is square 2, this is square 3, square 4 should be around this side, square 5 should be around the side, and square 6 should be at the back. So that makes it 6 shape. So its surface area is calculated as 6 times, what is the area of a square? You know, a square has both length and breadth of the same size. Their magnitude is the same. Length and breadth of a square is the same. And a cube is made up of 6 squares joined together. Therefore, the surface area of a cube would be 6 times area of one face, which is x squared. That makes it 6 times x squared to give us 6x squared. That is the formula to calculate the surface area of a cube. How do we calculate the volume of a cube? The volume of a cube is equals to its length times breadth times height. Don't forget, it is known that squares, 6 squares to be particular, made up a cube. And then we know that all the sides that made up a square are of the same length. The length is the same as the breadth. The breadth is the same as the height too. So this makes it a uniform magnitude. So the volume of a cube would be the length times the breadth times the height. Let us try to locate that on the cube. This is the length of a cube. This is the height of a cube. And this is the breadth of a cube. So because they are of the same magnitude, the volume of a cube is given as x times x times x. And that makes it what? X cube. Cube of x. X in 3 places. X times x times x gives you what? X cube. Let us have an example for better understanding. Example 1 says, a cube has a length of 5 centimeters. Calculate 1. Surface area, 2. Length of a diagonal, 3. Volume. You know, like I'll always tell you, the first thing to do when you see a mathematics question is what? There you are. The first thing to do when you see a mathematics question is to try to analyze the question, interpret the question, and understand the question. You cannot just start off to solution or to solving a particular question, whereas you don't know what you are asked. You don't know your direction. So now let us try to analyze this question. A cube was mentioned. A cube is a solid shape and has 6 faces. It has a length of 5 centimeters. This tells us that once the length of a cube is 5 centimeters, automatically its breadth is 5 centimeters as well. Its height will be 5 centimeters as well. Why? Thank you. Because its length, breadth, and height has the same magnitude. It is made up of 6 regular squares. So now, we are told to calculate the surface area of the cube, the length of a diagonal of the cube. What do we mean by length of a diagonal? You are given a cube as this. Yeah, that is a cube. The length of a diagonal of a cube. Let us try to locate these edges. Let us try to name them. Let us name this A, B, C, D, E, F, G, H, I, and J. Right? The length of the diagonal of a cube is that line that will come from B the side from the bottom of B here to the top of E. So this line is the diagonal line there, and the length is what we are told to discover. Don't panic and don't worry. It is not something hard. Just follow me. Let's take the question again. A cube has a length of 5 centimeters. Calculate 1. Its surface area. 2. Length of a diagonal. 3. Volume. Let's try to solve this. We were given in the other slide that the surface area of a cube is what? 6x squared. Good, let's move on. So 6x squared. But we have our x given to us in the question as what? 5 centimeters. The value of x according to the question given is what? 5 centimeters. So if you put this 5 centimeters in place of x, you would have 6 multiplied by 5 squared. So that gives you 6 times 5 squared is what? 25. 6 times 25 would give you 150. What is the unit to calculate an area? Any area given is always calculated in squared units. We are using centimeter squared because our question is given in centimeter. What if our question is given in 5 meter? That means the unit to use here will be what? 5 meter squared. Anything you calculate and it deals with area is always squared. Is that taken? Let's take that again. Surface area equals 6x squared, but x is equals to 5. Therefore, 6 times 5 squared equals 6 times 25 equals 150 centimeters. This is the surface area of the cube. Let's try to calculate the length of diagonal. The length of a diagonal of a cube is given as x root 3. What did I say? X root 3. X root 3. That is the formula to calculate the diagonal of a cube. But according to the question, our x has already been given as 5. What do you have to do? Just substitute 5 in place of x and try to solve. So when we do that, we would have x root 3 would give us 5 root 3. 5 root 3 means 5 multiplied by the root of 3. The root of 3 is what I want you to press with your calculator. What does it give you? 5 times root of 3. Calculate root of 3 first. Press onto your calculator the square root of 3. What does that give you? Good. Multiply it by 5. Yes, it gives you 8.7 centimeters. The question is to calculate length, not area. That is why our centimeter does not have a square. Did you take that? 8.7 centimeters. Let's read the last question. The last question says we should calculate the volume of the cube. Volume of a cube, the formula to do that is given as x cube. X cube meaning x times x times x. According to the question, our x is 5. That would be what? 5 cube. 5 cube meaning what? 5 cube meaning 5 times 5 times 5. And that gives you what? 5 times 5, 25. 25 times 5, that is 125 centimeter cube. Did you notice the cube there? Yes, that is because we are dealing with volume. When you are told to calculate the volume of any shape, okay, you calculate the volume and put the unit in cube. If the unit is in meter, that means your volume will be what? Meter cube. The unit of your volume will be what? Meter cube. But in this case, our unit is centimeter. That is why the unit of our volume here as well is what? Centimeter cube. Is that taken? Good. Let us quickly recap before we move on to the next slide. we were talking about cube, and then we said a cube is made up of 6 squares. It has 6 faces of equal dimension. The word equal dimension is relating to its length, its breadth, and its height. They are all the same. The dimension of the length is the same as the dimension of the breadth, and as well the dimension of the height. So because of that, we have the formula of the surface area of a cube to be 6x squared, and the formula to calculate the volume of a cube to be what? X squared. So we have an example to test our understanding. The example says a cube has a length of 5 centimeters, and we are told to calculate its surface area, its length of a diagonal, and its volume. From the other side, surface area is 6x squared. 6x squared, putting 5 in place of x, would give you 6 times 5 squared. 5 squared means 5 times 5, and that gives us 6 times 25. And the final answer to be 150 centimeter cube. Don't forget to put your unit. Length of a diagonal BS is given as x root 3. X root 3. Substituting the value of x, which is 5, makes it 5 root 3. And that gives us the answer, the value of 8.7 centimeter. To calculate the volume of a cube, the formula to do that is given as x cube. Substituting the value of x, which is 5, would make it 5 cube. And 5 cube means 5 times 5 times 5. And that is what? 125 centimeter cube. Is that taken? Good. The next slide is a quick exercise. At this juncture, I would want you to pause this video and read the exercise, analyze it, interpret it, understand it, and solve this question. Solve the question before you move on to the next slide. Now, let's talk about cuboid. A cuboid is a solid shape with a rectangular base and sides. This categorically has a rectangular shape embedded in it, unlike the cube that we talked about the other time. It has 6 rectangular faces if all sides are closed. Give me a perfect example of an object that has the shape of a cuboid. Thank you. A matchbox. A matchbox has the shape of a cuboid. If you study your matchbox very well, you would know that it has 6 rectangular faces. Are we together? Not only the matchbox, try your Indomie box. Yes, that's very. Another example of an object that has the cuboid shape is the carton of your Indomie tables carton. Yes. So a cuboid has 6 faces, just like a cube. But in this case, the faces are rectangular. Okay? They are rectangular. And then it is only 6 if all sides of the shape is closed. The moment you open your Indomie carton and the top face is opened, we can't call it a cuboid that is complete. We can't call it a complete cuboid again. Okay? That is an entirely different cuboidal shape, and it requires different words understanding. So let's say we have a cuboid whose all sides are closed. The surface area of cuboid is given as 6 rectangles, and that is what? 2xy plus 2xz plus 2yz centimeter squared. That is the formula to calculate the surface area of a cuboid. Let's take this formula again. 2xy plus 2xz plus 2yz. Did you know what these terminologies mean? No. This side of your matchbox is the side that you normally glide your matchstick on to bring about the fire, isn't it? Will you compare this side to the top part of your matchbox? No. Even though the both of them are rectangular in shape, a particular side is bigger, a little bit wider than the other side, isn't it? Yes, the top side is wider than the side. Will you compare these two sides with the one you have here? No. So this tells us that even though a cuboid is made up of 6 rectangular faces, each of these rectangles are not of the same dimension. They are not of equal dimension. And that is why we cannot have 6x squared as its formula, just as we have it in the cube. So because of that, we know that this type of side occurs twice. This type of side occurs twice. And this side too occurs twice. So because of that, we have 2xy plus 2xz plus 2yz. Each of these two is telling us that each of the sides that look similar are taken together. That is the formula to calculate the surface area of a cuboid. The length of diagonal of a cuboid is given as square root of x squared plus y squared plus z squared. Okay, the square of each of those sides. Are we together? That is the formula to calculate the length of a diagonal. And don't forget, the unit will be in what? Centimeter or meter. How do we calculate the volume of a cuboid? The volume of a cuboid is calculated as its length times its breadth times its width. Okay? Length times breadth times width. X, Y, Z centimeter cube. Let us take an example for better understanding. Example 2 says a cuboid has a length of 13 centimeter. What is the length? 13 centimeter. Width of 9 centimeter. And height of what? 8 centimeter. Good. Let us say x is equals to length and y is equals to what? Width. And z is equals to height. How do we calculate? Your x is the length, your y is the width, your z is the height. We are now told to calculate the surface area, the length of its diagonal, and the volume. Solution. To solve this, the surface area of a cuboid is given as 2xy plus 2xz plus 2yz. As a mathematics student, look at this and tell me what is common to all these families. Thank you. 2 is common. Try to bring it out like this. Open a bracket for the other family. No, x is not common. We have x here. We have x here, but there is no x here. Y is not common as well because there is no y here. Are we together at all? Okay, let's move on. So the common entity here is what? Is 2. Now put the remaining family back into the bracket. We have xy plus xz plus yz. Then close your bracket. This formula is the one I give you here. Okay? Now let's move on. So we say 2 open bracket xy plus xz plus yz close brackets equals, your 2 is here, 2. Open a big bracket. Now xy means what? Length times what? The width. You know, I said your x is equals to length and your y is equals to width. So that will be what? 13 times 9 as we have it here, plus xz. Xz is what? 13 times 8 plus yz. Your yz is what? 9 times 8. Good. Let's solve this. So now 13 times 9 is what on your calculator? Do that now. 13 times 9. You can as well use your pen and paper to calculate. 13 times 9 gives you what? Thank you. 117. That is it there. 13 times 8 is what? 104. Thank you. Don't forget your plus. Then 9 times 8 is what? 72. If you try to add these 3 numbers together, what will it give you? 293 multiplied by 2. And that gives you what? 586 as your final answer. Look at that solution 1 again. Surface area is equals to this as the formula. If you put the formula, you would have this. If you simplify further, you would have this. Further simplification gives you this. And a final simplification gives you your final answer, which is what? 586 centimeters square. Good. The next question we are told to look for is what? Length of its diagonal. The formula to calculate the length of the diagonal of a cube is what? Yes, the square root of the squares of each side. Square roots of the squares of each side. The formula is given as x squared plus y squared plus z squared. Isn't it? Yes. So now, this is what I have here. X is given as 13, isn't it? 13 squared plus y is given as 9. 9 squared plus z is given as 8. 8 squared. 9 squared is 81. 13 squared is 169. 8 squared is 64. If you add all these together, it would give you 314. Don't forget your square root. We still have the square root there. So simplification of this, that is the square root of 317, gives you 17.72. Approximately 17.7 centimeter. Is that taken? Look at the solution 2 again. The length of diagonal equals to this formula. Yes, substituting the value of those letters would give you this. Further simplification would give you this. Simplifying further would give you this. After which you arrive at your final answer, which is this. Now, we are also told to calculate the volume of the cuboid. The formula to calculate the volume of a cuboid is given as what? Yes, multiplication of all the sides. Length times breadth times height. Oh yes, another name for breadth is width. So it can be length times width times height. Are we together? So that is what? X times y times z equals x, y, z. Are we together? So that is what I have here. X, Y, Z. X is 13, Y is 9, Z is 18. 13 times 9 times 8 gives you 960, 936. And our unit is what? Centimeter cube. Don't forget your unit at any point of time. No unit, no mark. Try this quick exercise. The exercise reads, a cuboid has a length of 15 centimeter, width of 10 centimeter, and height of 4 centimeter. Calculate its surface area, its length of diagonal, and its volume. At this juncture, I will need you to pause this class and take your quick exercise. Yes, do it in your notes before you proceed to the next slide. Thank you. Here we are again. We'll be talking about another solid shape. Cylinder. Cylinder. Cylinder is a solid shape and it is a prism whose cross-section is a circle, e.g. a melotin. A melotin has a circular top, a circular base, and a curved surface area at the middle, isn't it? Let us roll. The curved surface area of a cylinder is given as its base circumference and height. What is the base circumference of a cylinder? The base circumference of a cylinder is like trying to find the circumference of a circle. And the formula to do that is what? Thank you. 2 pi r. Okay? So 2 pi r is the formula for the base circumference of a cylinder. So multiplying it by the height of a cylinder would give you 2 pi r h. I deliberately put that centimeter square to remind you of the unit. When you are talking about area, anything area, whether curved surface area or total surface area, always put your unit in squared. If you are dealing with meter, your unit would be meter squared. And if you are dealing with centimeter, your unit would be what? Centimeter square. So the curved surface area of a cylinder is given as base circumference. So the curved surface area of a cylinder is given as its base circumference multiplied by the height. Okay? The height of a cylinder runs from the top to the bottom of the cylinder. This is the height of the cylinder. Are we together? Now, how do we calculate the total surface area when both tops are closed? When both tops are closed simply means when you have not opened your melotin. You know, there is no way you can open the melotin from the bottom. Okay? You only open from the top. But if we are citing an example using a tin of milk, like lunar milk, we cannot say specifically which part is the top and which part is the bottom. We choose to open a lunar milk on any side that we deem fit. But here, I want to specifically cite a melotin as our example for better understanding. So now, the surface area of a cylinder when both tops are closed is equals to the area of the base, which is a curved surface area, which is the one at the middle, and the area of the top addition of all these three areas would give you the total surface area of a cylinder. Is that taken? This is not a hard mathematics. The top part of a cylinder has a circular shape, isn't it? What is the formula to calculate the area of a circle? As simple as that. The formula is pi r squared. Good, thank you. What is the formula to calculate the curved surface area of a cylinder? Yes, this is what we have here. 2 pi r h. And then what is the formula to calculate the base area of a cylinder? The base area of a cylinder also has a circular shape. Therefore, the area of a circle is still what? Pi r squared. If you put this here, you would have pi r squared plus pi r squared plus 2 pi r h. Okay? Pi r squared plus pi r squared would give you what? 2 pi r squared. Is that taken? Then plus 2 pi r h. That gives you this. If you look at these two families very well, 2 is common, pi is common, r is also common. So now, let us try to bring out the common entities. We have 2 pi r as the common values, right? Now, we'll be left with r plus h. The r on this side is a squared r. We've removed 1. We put 1 out here. So we'll be left with 1 more r, which is that. And then on this side, 2 pi r has been taken out here. We'll be left with what? H. Very good. And that is that on the other side. So this gives you the final formula to calculate the total surface area of a cylinder when the two circular ends are closed. So that is what? 2 pi r, open bracket, r plus h, close bracket. Don't forget your unit. How do we calculate the total surface area when the top is opened? Let us take this as your Milo tin. Now, you have opened this lid for you to take Milo away from this thing. You know, and someone approach you that what is the total surface area of what you have left as a cylinder? Don't forget, the top has already been opened. What would that give you? Since the top has been opened, that means the top has been cut off and we no longer have a top for that particular cylinder again. So what are we left with? We are now left with the curved surface area and the what? And this area. So the area to calculate total surface area when the top is opened is now area of the base plus curved surface area. Area of the base is given as pi r squared and the area of the curved surface area is given as 2 pi r h. Is that taken? Look at the two families. What is common? Pi r is common. Thank you. Bring it out. Write the remaining entity into the bracket. And then don't forget your units. Are we together? That is the formula to calculate its surface area when one top is opened. How do we calculate the volume of a cylinder? The volume of a cylinder. How much Milo can a Milo tin take? That is what is meant by the volume. To calculate that, we say base area of the cylinder, height of the cylinder. The base area of the cylinder, which is pi r squared, times height of the cylinder, which is h. That gives you pi r squared h. Don't forget your units. We are dealing with volume now. That is why my unit is in cube. Is that taken? Let us have an example for better understanding. Example 3 says, a cylindrical container has a base radius of 6. Radius is the R that we've been seeing from the former formula. Are we together? The radius is the R that we've been seeing. So now the base radius is given as 6 centimeter and its height is given as 17 centimeter. Calculate its total surface area. 2. Calculate its curved surface area. 3. Calculate its volume. I will give you 10 seconds to read the question again. Read it out loud. Yes, you need to help yourself. Read it out loud. Try to understand the question. Your 10 seconds starts now. Thank you. According to the question 1, we are told to calculate the total surface area. Look at it. It was not stated whether the cylindrical container, whether the top has been opened or not. So to be on the safer side, we will calculate the total surface area for the 2 cases. We will calculate whether the top was not opened, and we will calculate whether the top was opened. Are we together? Let us solve. So now, question 1. To calculate the total surface area when the cylindrical container top was closed. Don't forget, the formula to do that is what? Thank you so much. The formula to do that has been given in the previous slide, and this is it. So now, this is what we have here. If you try to put in the values of what we were given from the question, you would have our 2 is here. Pi is given as 22/7. That is the general value for pi. If you don't want to represent it as 22/7, you can simply represent it as 3.142. Do you understand? Good. So now 2 multiplied by pi, which is 22/7, multiplied by r. Our r is the radius and it has been given as 6 centimeter. That is what? 6. Open brackets, r plus h. Our h is the height, and that is what? 6 plus 17. Solve what you have in the brackets first, following the BODMAS rule. So you would have 6 plus 17 to give you 23. Now, 2 multiplied by 22 multiplied by 6 would give you 264/7. Okay? Now, 264 times 23 would give you what? I need to warn you at this age, don't use your over. Do not write your over like this in your notes. Please, write your over, that sign, correctly as 22/7. Do not write 22/7. Okay? If you do that, you might be confused. Are we together? So now, we have 264 times 23/7. That gives me 6,072/7. If you simplify that, it gives us our final answer. And that is the value for the total surface area of the cylindrical container when the top is closed. How do we calculate when the top is opened? Don't forget, you have your formula given here. When the top is opened, we have this formula, pi r, open bracket, r plus 2h. That is what I have here. If you try to put the values there, your pi is 22/7, r is 6, right? Now, r plus 2h, 6 plus 2 times 17. Take it one step after the other. 22 multiply by 6. Open bracket, 6 plus 2 times 7 is what? 34. Everything all over 7 would give you 132 times 40 over 7. The 40 is gotten from 6 plus 34, right? So now solve further will give you 5,280 over 7. I want you to simplify. Yes, divide 5,280 by 7. What did that give you? 754.29. Good. And that is the value for when one top is opened. Okay, don't forget to put your unit. No unit, no mark. Question 2 says curved surface area. The formula to calculate the curved surface area of a cylinder is what? 2 pi r h. Good. So putting your values there would give you 2 multiplied by 22 over 7, which is your pi, multiplied by r, which is 6, multiplied by 17, would give you 4,488 over 7. Check it up yourself. Calculate it. Did you arrive at my answer here? Well done. And the last question here says we should calculate the volume of the cylindrical container. The formula to calculate the volume of a cylinder is given as pi r squared h. Our pi is 22 over 7. Our r is 6. So because the r has square here, you must square your 6 too. Then our h is 17. If you simplify this, what will it give you? Did you arrive here? Good. Simplify further. Did you arrive here? Well done. And then your final answer would be what? 1,923.4 centimeter cube. Clap for yourself. You are not too big to clap for yourself, you know. Good. Take this quick exercise. Well, I don't write quick, but I assure you it is not a long exercise because you have time. There is time for everything. So you have 3 questions. The 3 questions are based on today's class, which is on cylinder, on cube, and on cuboid. Read these questions, solve them, make sure you do them right. And in our next meeting, we shall be discussing the other part of solid shape, the other part of solid mensuration, talking about sphere, pyramid, and cone. Thank you. See you some other time.